Good evening, and we are live with our live chat in the middle of a very impressive storm. We've had heavy rain, thunderstorms, reports of hail, literally observations of hail on X and on Facebook and on our Discord forum, which has been outstanding. As always, providing great analysis and observations. That's pretty cool. Great job, guys. Just so you know, I do have a generator and we will keep power. Only problem is that the internet might not last because we have been getting flickering. We have strong winds out here. So if I automatically somehow disappear, that'd probably be the reason why we keep the power. But whether or not the internet will still be working is another question altogether. So fingers crossed. In the meantime, let's talk about this storm, which has been evolving and really has been featuring three parts. The first part came through on Monday and Tuesday, which featured our isotropic lifting as the warm air tried to push northward, and we had waves of rainfall and breaks of rainfall as well. Then we had part two, which is the primary low pressure system in the upper Midwest lifting up towards the central Great Lakes and rapidly intensifying. This drove warm air at the mid levels up into New England, leading to widespread heavy rainfall, and that has been from last night to now. Now we're entering part three. Part three is where we get the primary low shifting towards the coast. And now we get a nor'easter. With that, the potential for snow in New England and maybe even the Poconos and Catskills as cold air transport comes in. I'm not expecting much accumulation around here. Maybe a dusting of your highest elevations, right? But unfortunately, especially if you're going to a doubleheader tomorrow for the Mets, you might be dealing with some rain and snow showers even in the afternoon hours. It's going to be pretty unstable. So let's take a look at the observations and see what we have here. And of course, once we go through all the observations and I go through all my spiel, I will, of course, take all of your questions, which are already starting to load up very nicely here on the chat on nyjpaweather.com. Again, premium members get all their questions answered, and as they ask, right? And then we check out YouTube and X and see if there's anything going on out there, which looks like right now. I have to admit, the background looks pretty good with all the Godzillas. If you have not seen the Godzilla movie, I suggest you do so because it is the only movie. It's not only a fantastic movie, but it is a movie in which the critics panned, which means that you know it must be good because every time the critics say a movie is bad, it ends up being good. And when they say it's good, it ends up being bad or boring. So definitely go and see it because it's well worth it. So let's dive into these observations. Okay, good. Now, this is the surface observations. I always use this first when forecasting. And the reason why is this. Radar can fool you. Satellite data can be missing, but observations, well, they tell you what's really going on. And what's going on, a very important observation, is right around the Delaware Bay. We're starting to see our secondary low pressure system really start to take hold and really start to become the primary low. That process is happening right now. And so what's happening, you're starting to see the winds backing from the east and northeast at 10, 20, 25 miles per hour to the north and eventually from the northwest. You can see the circulation right here starting to get itself organized. And the reason why this is important is because we still have that threat for coastal flooding. But once we start to get the winds out of the northwest, that threat starts to subside. So that process is starting to come to an end with the consistent northeasterly winds. We're also starting to see the heaviest precipitation start to shift away from our region. Notice you're starting to see colder air at the surface, at the boundary layers, starting to get drawn south from New England and from northern New York down towards the northern mid-Atlantic. And as a result, we're starting to get results in the Poconos and the Catskills and portions of the Hudson Highlands. By the way, if you don't know what the Hudson Highlands are, that's basically northwestern New Jersey, or northern New Jersey, really. Portions of the Hudson River Valley, especially the ridges around the Hudson River Valley, and northern and northwestern Connecticut. That whole area, that whole rise in elevation, that is called the Hudson. That is called the Hudson high rise there. So that area is where we're starting to see the evolution of some of that sleet mixing in. So don't be surprised to hear a ping here and there while all this is going on. While that is going on, we're also getting thunderstorms. We had severe thunderstorm warnings here. Now, you might be wondering, and you're looking at the temperatures here, Stephen, we're in the 40s and 50s. How are we getting a severe thunderstorm warning? How are we getting any thunderstorms? And that's where the SKU-T comes in. Take a look at this. This is, again, from Tropical Tidbits, so you could pull this up pretty easily. What's happening here is that the mid-levels of the atmosphere, above roughly, let's say, 850, 825 millibars, that portion of the atmosphere is unstable. Now, remember what I said when we were talking about the parts. Part 2, where we had that warm air surge in. So what's happened is that at the lower levels of the atmosphere, we have a marine air mass in place. From the Canadian maritime air mass that has been sitting around the Gulf of Maine, comes on in via that northeasterly wind, right? But at the mid-levels, right here, that's where we have warm air surging in. And that warm air surging in is creating, let's say, a buffer. So let's pretend that instead of this stable area, you get your SKU-T starting here at about 850, right? So let's pretend we're at that is our surface. So if this sounding was at the surface, we would be saying, wow, look out for strong to severe thunderstorms. In this case, we have more elevated thunderstorms. And because of the changing dynamics of the storm going from the primary over the Great Lakes towards the northern mid-Atlantic, is creating mixing. So now you have elevated thunderstorms with heavy rainfall and occasional flashes of thunder, and the strong wind gusts that are associated with those thunderstorms are now being completely mixed down to the surface, which introduces the potential for severe thunderstorm warnings. Now, to be honest, I didn't think we'd get that type of full mixing. I like the idea of embedded thunderstorms, but I didn't think they reached severe levels. But because of the strong winds at 850 millibars, those strong winds were able to get mixed down within those thunderstorms to signify the observations to call these thunderstorms severe because of the wind gusts. So it has been very impressive in terms of those thunderstorms. And this is a great example of what happens when you have a stable surface, but the mid-levels are unstable, and that leads to your elevated thunderstorms. So if you ever get a question of whether or not that's actually happening, definitely check out Tropical Tidbits, free website. You can go right to the mesoscale data, click on it, and boom, there you have your SKU-T. This is a great tool to use. I strongly suggest learning more of it and studying it. You can also click this link here and learn more about the soundings as well. So great learning tool. So there is our radar right now. Oop, of course, let me fix that because sometimes that happens. Okay, good. Okay, so there's our radar and surface map. You can see our new low pressure system starting to organize here. And you can see another low pressure system back here. This is our triple point. And then here's our primary low. Now what's going to happen is that the primary low is going to start to weaken. It's going to become what we call vertically stacked because the upper level low is right over it. And your new secondary low is going to basically congeal into one storm here and lift up towards the New Jersey coastal waters. While that's happening, we're kind of in this in-between lifting period. So your initial strong lifting that drove all the rainfall the past 2 days is now lifting up to New England, interacting with that cold air, which is supporting the development of that snow. We're just at the infant stages. And so as a result, we start to break up the precipitation shield a little bit. This is a time period where typically when we're in the middle of winter, everyone thinks that the storm is not going to develop or dry slotted or the storm's going to bust and all this other nonsense because there's no patience. What we're dealing with now is a new storm forming. So you start to see already the precipitation starting to redevelop here around Virginia. Now, that whole process gives the Phillies right now a chance to actually play their baseball game because they are literally in the area that is in between the previous lifting and the new lifting that's starting to show up. So the fact that they're working right now on this game, and let's see what the score is right now. We'll pull that up. And right now it is 0-0 in the bottom of the first. So they picked a good time to start their game. And considering the way the pitching is today, they should be able to get the whole game in, or at least make the game count. You know, once you get beyond, 5 innings, I think. So we have that set up. So we have that starting to set up here with the evolving storm. And what you're going to see over the next several hours is this area of precipitation blossom and lift up towards the northern mid-Atlantic with another round of heavy rainfall. But this time, because we're starting to get the new primary take over, colder air is going to get pulled down towards the coastal plain. So what does that look like? Well, let's see here. Let's pull up the SPC. And at 925 millibars, you start to get your new 925 millibar low forming. Now, remember we were talking about some of that sleet in the Hudson Highlands and in the Poconos and Catskills? Take a look at the cold air that's starting to pull in. Now, remember, at the surface, we're still well above freezing, so we're not worried about any type of snowfall accumulation or whatnot. It's not that type of scenario. But you can see why we are seeing the mixing showing up in several observations. It's because that cold air is starting to get pulled in. When we take a look at 850 millibars, you can see even better the start of this evolution. So, again, the primary is around Lake Michigan, but it's starting to weaken. It's starting to collapse. And the new one is starting to take place right around Pennsylvania. So why do we have the 850 millibar low here? Now, in the winter, this would be a big deal. This would be like, okay, it's going to be raining on the coast. There's no way of any type of snow accumulation because the transfer is too far west. Right now, it's not that big of a deal. It still means a significant storm. But why do we see that? The reason why is because cold core storms, okay, extratropical storms are stacked in an angle. Okay, so on the camera, it's like this, okay? So what does that mean? It means that your surface low is out here, your 9 to 25 millibar low is here, and your 850 millibar low is here. What this means is that the cold air gets delayed to get pulled down towards the coast, but it's close enough over the interior to start to set up that transition of rain mixing with sleet and snow and eventually changing over to snow. This is why I've been saying for several days, especially premium members know this, watch out for slick roadways and icy roadways tonight into tomorrow morning for the highest elevations of the Poconos, the Catskills, and the Hudson Highlands, because you're going to see not necessarily a great deal of accumulation unless you're on the grass, but plenty of slick conditions, especially on your secondary roadways. So you're seeing that whole process take shape. Well, what about the 700 millibars? Let's take a look at that. In fact, before we do that, let's take a look at that frontogenesis we were talking about. Now notice, look what we have playing out here. you have one area lifting here around Washington, D.C., where we're starting to see the new precipitation take place. And there's our 850 millibar low trying to organize. There's our second phase of lifting that created all the precipitation earlier this morning. So what you're dealing with here is this interaction of all these different air masses. And at 850 millibars, the tropical air mass is one. At the surface, the tropical air mass lost. It did not get far enough north. In fact, the forecast high that I was expecting for Philadelphia at 61 busted by about 15, 16 degrees because it never got anywhere near that. Why? The warm front at the surface didn't get far enough north. But at 850 millibars, it blew right through. So that's why you're seeing all these different lifting parameters. And because of that, as the new secondary takes hold and we start to get the polar air to come in and interact with these three different air masses, you end up with this rapidly intensifying surface low pressure system. So at 700 millibars, you can start to see, again, a slight indication of that push to the east. Not so much at 500 millibars. 500 millibars, that upper level low is very strong. So why is all this happening? Why are we seeing this shift to the coast? Well, let's take a look at the upper level winds. Again, this is from Earth News School, completely free. Definitely check it out. earthnewsschool.net. So definitely check that out. Look at the way this pattern is set up. The reason why this whole evolution is taking place is because of that block. This block is preventing any type of evolution of this low pressure system from getting any further north into the St. Lawrence River Valley or heading off into Quebec. So it has to get forced towards the coastal plain. It cannot lift any further north. So as a result, because of that, you get your redevelopment towards the mid-Atlantic coast and to the south of Long Island. That's why we're seeing this process take shape. So would this pattern work out in the winter? Great question. The reason why this works out now is because the wavelengths match up. But, and I got this question before, so I figure I knock this out right now. You see this trough here along the west coast? If this was occurring, let's say in January or early February, the amplitude of this trough would have kicked this whole setup further to the east. But because of the nature of the polar vortex getting completely destroyed and now fading away, because we're seeing that shift of the polar jet stream on average to the north and the wavelengths getting a little bit broader, and because of the state of the changing dynamics in the subtropical jet stream with El Nino going to La Nina, this storm works out just right. Again, this is a great example where timing and location worked out, and where a lot of people get stuck with the alphabets, in trying to forecast the weather. But sometimes what you have to do is look at the environment that this whole storm is playing in to understand how we got here. And the reason why we got here is because you have a lot of different changing dynamics in the atmosphere. And because of that allowed that block to sit right where it's at over northern Quebec and just south of Greenland to allow this whole setup to take place. So this is a perfect case of not always a textbook situation leading to a pretty impressive storm. So on the infrared satellite picture, just want to point out this strong lifting out here that's pushing out towards the Atlantic. That's our moisture transport from the subtropical jet stream getting kicked out into the Atlantic. And now you're going to see this pivot. You can already start to see that pivot starting to shift towards New England as our new secondary low takes shape. And that shows up very nicely here on the water vapor satellite picture. And look at the extent of this storm. The moisture transport starts out here towards the convection in the southern Pacific, lifts up through Mexico into the Gulf of Mexico, up the East Coast and right into our neck of the woods, wrapping around this upper level low. As this upper level low pushes east, all this moisture gets thrown right into ski country, into northern New England, the Green and White Mountains. So if you like skiing, looks like it's better off to go skiing around Easter than it is to go around Christmas. So especially this year, because they're getting plenty of snow out of this storm. Very impressive snowfall out of this. So there is our evolution of our storm. As we go into tonight, into tomorrow morning, our upper level low will gradually move towards our neck of the woods. We'll start to see a back off in the precipitation, but because the upper level low is going to be lingering over us for tomorrow onto Friday into Saturday, will remain unsettled. And that's why we're seeing the potential for scattered showers through that period. And while that's happening, you're going to have plenty of cold air aloft. So what does this do to our weather pattern? Well, it keeps us unstable. So during the day, we'll have these convective showers popping up. But because of the cold air aloft, don't be surprised if we get some sleet and snow mixing, even down towards the coast. No accumulation, but just don't be surprised if you see a snowflake here or a little bit of sleet mixing in. Now the good news is that cold air rapidly gives way and we start to shift towards a warmer weather pattern. Just want to go over the HRR guidance. You can see our storm lifting up. There's that snowfall that shows up over the interior. So right now we're seeing the worst of these conditions. Let's pull up the newest HRR. There's our heavy rain that develops in Virginia, lifting up right through Pennsylvania. Again, keep an eye out on the Poconos. Okay, again, the boundary layer temperatures are not all that impressive, so I really don't think any problem's going to show up on the streets. But when you drive tomorrow morning to work, just use some caution out there, because I think that some of those secondary roads, maybe your driveway, some sidewalks, are going to be a bit slick. So use some caution out there, because that's going to be a bit of a concern. Now let's see if the Mets doubleheader has a shot here. Well, the bulk of the steady precipitation will be to our north. So yeah, there's a pretty good shot that you'll get both games in if you're heading out there. I got a couple email questions about that. So definitely that looks pretty favorable. On the European guidance, it has handled the storm relatively well. A little bit too aggressive with the snowfall over the interior, but other than that, pretty reasonable for this type of complicated storm. Now remember what I said about the warm air aloft supporting the potential here for some real clash of these air masses, right? Look at how fast this low bombs out, down to 986 millibars. That is impressive, ladies and gentlemen, and that is going to lead to some very nasty weather conditions by tomorrow morning for southern New England. So especially around, let's say, Connecticut, Rhode Island, Massachusetts, driving heavy rain, strong winds. Long Island, you'll be pretty nasty too. You'll start to see improvements around the Philadelphia metro and the New York City metro right around the start of tomorrow morning's rush hour. So that's certainly some good news in that respect. It will still remain unsettled and a passing shower here and there, but at least it won't be the driving rain that we're seeing now and the strong winds. That'll start to back off. After the storm exits, here's the good news. This weekend we start to gradually improve. We start to gradually moderate. By Sunday, it would actually be sunny. So if you're missing the sun, Sunday is the day that you can look forward to all that. And then everyone's asking about Monday. Now, I am going to be updating. I've been updating and will continue to update the eclipse forecast. It's under Stephen Thoughts on the premium dashboard. So check that out. I've been updating that every day. The best thing I can tell you about that time period is that there's going to be a mix of sun and clouds. in the Ohio River Valley up towards the eastern Great Lakes. So this is pretty much where everyone's trying to flock to around here to see the eclipse. I cannot in any way, shape, or form forecast completely clear skies for wherever you happen to be going. There's going to be that chance, based on the way that the guidance has been evolving over the past couple of days, for some cloud cover. So I think we'll get a better idea on the nature of the cloud cover for the region probably once we get under 90 hours, because usually cloud cover forecasts, it's a little bit unreliable beyond 5 days. Unless you actually have a major storm, then it's obviously a little bit more reasonable. But what we have here is more of a weak shortwave moving through, so sometimes the cloud cover could be a little bit more robust than what it actually ends up being. But right now, that'd be my best call, is that mix of sun and clouds. If you're looking forward to seeing the eclipse, I don't think you'll be disappointed. But at the same time, I can't forecast completely clear skies in any of these scenarios as of yet. So just wanted to touch on that. Now, our pattern going through for the rest of April and I think into May is going to remain active. We're starting to see a lot of changes, though, taking shape. I mentioned one of them today in the long-range thoughts about the fact that our QBO is changing and what that will do to pull the polar jet stream northward. We're seeing a lot of changes in tropical forcing, especially with the changing MJO. And of course, it's going from El Nino to La Nina. But one thing that seems to be standing out here is the potential for these pesky upper level lows to become an issue. And that opens up the potential for backdoor cold fronts, slow moving warm fronts, and essentially unsettled weather conditions. But I think we trend more towards slightly above normal for the rest of this month, but we still remain active. I don't expect the type of major rainstorms that we're seeing right now, but I think we'll start to see more in a line of cold fronts with the potential for thunderstorms creating heavy downpours and stuff like that. So we'll start to shift towards that type of scenario. And you can see that's showing up nicely in the European ensemble guidance with more progressive cold fronts. And also notice, we're starting to see more support for those high pressure systems out here in the Western Atlantic, pumping moisture northward. Just think about that during the summer. That could become a bit of an issue. And of course, that leads to the interaction of more Pacific air masses moving forward and a general trend towards more milder conditions. A lot of these polar air masses that come through are continuing to moderate rapidly, faster than what the model guidance is suggesting. I expect that to continue to be a theme as we move forward through the rest of spring. So that is all of the data that I decided to pull up. Now let's see what questions you got. Okay, and we'll start, of course, with the live chat and see what we got here. Of course, we are always very active. So let's see here. Today was the first time I can remember ever getting exiting wake low winter weather advisory from NWS. What a wild weather day. Absolutely. No hail in my part of Union County, but definitely some lightning and thunder, easily 2 inches of rain plus. Yeah, we've gotten here in Freehold an inch and roughly an inch and a quarter so far today. So that is certainly some impressive stuff.
And some very impressive thunder earlier, too.
Yes, indeed. You said many times this past winter that the strong El Nino wasn't acting like one. That's true. Could the same thing happen with La Nina, i.e. it's strong but not act as strong as a strong one? I can't rule it out. The other La Ninas, the last recent La Ninas, they didn't act La Nina-ish in terms of the strength of the subtropical jet stream. And that is something that I'm definitely considering, why I'm saying that the pattern's going to continue to remain active, but the storm track is going to shift north. In terms of the pattern configurations, I think that'll work out. This is typical. In terms of the strength of the short waves that you typically see in El Nino and La Nina, so far that has not evolved as expected. In El Nino, we had we had a strong short waves as expected, but we also saw strong short waves in the polar jet stream, and they weren't interacting properly. Of course, now that it's spring, now they are. Go figure. With La Nina, the last La Nina we had, remember we had 3 in a row, so the last recent one, the pattern acted properly, as in the troughs and ridges and orientation of those features. But the strength of the subtropical jet stream remained pretty strong for a La Nina. Now, it's still weaker than what you would get with an El Nino, but it was still strong. And why is that important? Because those short waves being robust and being able to march across the Mississippi River Valley, up towards the Tennessee River Valley, and towards the Mid-Atlantic coast, they produced a lot of severe thunderstorms and very powerful severe thunderstorms. Remember, we had some impressive rainfall events in a La Nina year. So, when we look at this La Nina, not much has changed in terms of the evolution of the Pacific. It's warmer, in fact, so that's going to lead to a stronger thermal gradient at the boundary layer, enhancement for more convection, although that's going to be displaced. But the one difference could be the different QBO factor that could lead to a stronger stronger polar jet stream, keeping that polar jet stream up towards Canada. So there's a lot of factors to work out still, but that's certainly something that I'm trying to consider when I'm looking at the summer forecast and, of course, the forecast for the hurricane season. Sun has gotten rather quiet the past couple of days. Yeah, I don't expect that to remain like that much longer. I expect a big upturn in activity. Once you get below Interstate I-95 in South Jersey, the wind shear picks up as well. Yeah, that was certainly seen, again, at the mid-levels, not so much at the lower levels. And once the warm front started to get pushed through, then we started to see that more down towards Cape May. Two noticeable things from the SPC website: a large amount of 250 millibar divergence and 850 millibar convergence. Yeah, that would make sense over our area because right now we're on the eastern edge of the upper level low. So this area is a perfect area for strong divergence and diffluence. In fact, we can see that here showing up very nicely. And what's happening here, because of that divergence and diffluence going on, that's allowing your secondary low pressure system to rapidly intensify. Where was the cold air all season? Was an epic snow season we could have had. What a waste of 4 months of storms. Well, the cold air was there. Unfortunately, the interaction, just the timing. The one thing I'll tell you about winter storm forecasting, all that stuff, is that there are many years where you have almost everything in place. And all you need is one trigger to get things moving in the right direction. But if you don't get that trigger, you have the cold air, you have all the moisture, but they just don't come together. And that's incredibly hard to forecast for. That is something you put in your what could go wrong, which is one of the things I did. But you can't forecast for it. You can't, because it's a matter of trying to get perfectly timed short waves. That's why the truly historic winters that we get, cherish them, remember them, and in some cases enjoy them, okay, or profit off of them, because they're very hard to get. Because what you essentially have in those winters is every shortwave coming together just right. I'm not talking about one-off storm. When you're getting those type of winters where you're getting like 5, 6, 7, 8 winter storms evolving, That's a winter. That's a special winter where all your short waves approaching the mid-Atlantic are all working together to set up that storm threat. The blocking sets up. The orientation of the ridge in the west sets up perfectly. The orientation of each short wave. Those are rare and special seasons. And they're hard to come by. Which is why I always say every winter, every upcoming winter, we always have, what about 95, 96 or 2010, 2011? The reason why those winters are so special is because really special things happened. They're also very rare. So when I'm doing a forecast and I explain to people, okay, these are some of the factors that we're looking at, I stay away from using that as a template for the winter. What I always say is that when we bring up 95, 96, is this is a scenario, 95, 96 is a year that's similar if everything, I mean everything, goes right. But it probably won't. It can be very frustrating, though. I can understand that. When are we going to be done with this cold? In the upper 30s in East PA on April 3rd. When is actual spring coming? I'm over with this winter weather. We had 4 months to get winter and we didn't. Well, I mean, we certainly got more winter than the other years. That is for sure. But I would say that this is the last real strong polar shot that was associated with that whole disruption of the polar vortex. And from here on out, we will get polar air masses, but they'll be more and more modified and weaker. I can't say we won't get a cold shot because that's typical in April, but they won't have as much staying power. They'll moderate rapidly, and the daytime high temperatures will shoot up while the low temperatures will still remain a bit chilly. I am over 4 inches here in Levi Valley. One thing about this La Nina was the stronger than typical subtropical jet helped the Atlantic tropical season less than it would have without the active subtropical jet. Yes, but here's something to just take into consideration with that active jet. More potential for subtropical storms. Now, in previous years, we didn't name them. Okay? I remember a time where subtropical storms were just numbered, but they weren't counted as the part of the hurricane and tropical storm naming categories. Okay, now I'm dating myself. This is back in the 1980s and early 90s. They really weren't paying attention to them. They weren't pure tropical, so they didn't get a name. Now they get a name, and that starts to impact forecasting protocol. Because now I literally have to go with above normal season. Because if you're going to be naming every subtropical storm, then that's going to lead to an above normal year every year. Oh boy, that wind and rain is really rocking around here. We're actually starting to hear it pretty good here. So again, just a heads up, the lights start flickering or whatnot, but that'll be fine. But the internet could go at any moment. So just put that out there. The wind sounds like a little bit of a freight train a little bit. That's pretty impressive. Now let's take a look and see what we got on YouTube. See who takes best storm of the year as far as I'm concerned. We had a nasty thunderstorm here in Brooklyn. It's crazy here in South Brunswick. Yeah, it looks like it's a pretty good storm lifting up in that direction. Are we going to have a strong La Nina? Definitely moderate. Model data is a bit split on that. We need more data. Yep. Well, don't know yet. We'll circle back on that in about 6 months or so. Probably less than that, But I like the idea of moderate at the very least, based on the subsurface, but we need more data to really study that. Is the threat for severe weather diminishing as we go through the evening? Okay, so the winds will remain an issue regardless whether or not we have thunderstorms, embedded thunderstorms, because of the new surface low. So what you're going to end up getting is strong wind gusts continuing, the potential for power outages. I think we'll really get out of that severe threat and those type of impacts by tomorrow morning's rush hour. But overnight tonight, we continue to see that threat continuing. Okay. Any questions on X?
Nope.
All right, good deal. Let's see, what else do we have here? They should have stayed with numbering and only naming when necessary. Yeah, unfortunately, it's just unfortunately not something we can control, but I agree with you. It's a pain in the neck, but it is what it is, right? Let's take a look at our radar and see what we're dealing with here. I'm about to zoom in. Yeah, there is some of our embedded thunderstorms here. Now, what we should see going forward is that this low will start to become more dominant of any of these lows and basically jump to where this low is. So you start to see that change in dynamics starting to take shape. And this precipitation shield will start to expand. And you can basically see like basically the back end of the new storm starting to take shape. This will all fill in towards midnight. So again, you Phillies fans out there, you got a good shot of getting this game completed. Unfortunately, it looks like the Reds are already up 2-0. So gotta get knock in 3 runs and get the game to count. That's what you want to do. And then it doesn't matter. But it looks like our storm's starting to this is going to start to expand and grow and lift up right towards eastern Pennsylvania. But in terms of the thunderstorm potential, I think we're starting to back off away from that. We'll move away from that. But in terms of the sustained winds and the wind gusts, that's still going to remain a threat. Coastal flooding is going to remain a threat through this evening. Once we get past midnight, that's going to hit our tipping point where the worst conditions start to get focused more towards New England, and we start to see a reduction in the intensity of the winds and in the heavy rainfall. Tomorrow, though, it's still going to be windy and raw and ugly out, with the winds now coming in from the northwest, 10 to 20 miles per hour with higher gusts. Let's see what other questions we have here. Well, so far, it looks like I answered all your questions. So we'll continue to just watch the evolution of this storm taking shape here. And again, you can see how everything's kind of played out here with this upper level low sending pretty impressive thunderstorms moving into West Virginia. That is some strong thunderstorms. It's impressive just how dynamic this whole storm is in terms of the strong thunderstorms. We had severe thunderstorms in the upper Midwest and around Illinois and Iowa, and now we're seeing this whole system take shape here with this strong divergence in diffluence and all the vertical wind shear playing out in a perfect text-based scenario of a new coastal low taking shape. Let's see if we got any new data here on the infrared satellite picture. Okay, so you can start to see the new structure starting to take shape here in New England. Very impressive. And notice, just recently, cloud tops are getting colder here in Virginia. So what does that mean? We're starting to see more and more lifting starting to take shape as this feature it continues to get forced towards the coast. And you see that perfect divergence and diffluence. Again, you can see it very nicely here on the water vapor satellite picture, the perfect signal of our new low starting to take shape. Impressive stuff. Yeah, and there's our main precipitation. Should I say moisture feed? Lifting northward. Let's see what's going on in New England here. Yeah, now look at this. This is pretty cool. Because of the new storm starting to take shape, look at how the precipitation shield start to expand over northern New York. You're starting to see that colder air mix in and the snow starting to break out as a result of this. This area is going to see a rapid change in the intensity of the snowfall. And you're going to see snowfall rates are probably around 7-1 right now, jump up to 10-1 in New Hampshire and Vermont as the storm intensifies because the rising motion in the atmosphere will start to cool the whole boundary layer. Let's see what we have in terms of observations. Again, this isn't an Arctic air mass in any way, shape, or form. It's a marginal polar air mass, and you can see the marginal polar temperatures here. Temperatures in none of them are below freezing. We're all talking about 33 to 35 degrees. Under the area of strongest lifting, look off towards Maine, and you're in the upper 30s to lower 40s out here. Mid 30s in northern Maine. So this whole storm is driven by, in terms of the cold aspect of this storm, is driven by the strong rising ascent, cooling the atmosphere enough to support the changeover to snow. And at the boundary layers, your cold temperatures still remain above freezing. So this is a very wet, condensed snowfall. That's pretty impressive, right? In terms of this time of year. That's a pretty cool observation. Excuse me. Well, we got a couple questions here on YouTube. Which weather model would be good to look at to forecast cloud cover for the eclipse? There are so many available, I don't know which one I should focus on. Well, this is my general rule. Okay. In terms of where we're at right now, your best synoptic model is the European. In terms of mesoscale, I'd use the NAM once we get under 60 hours, and I would use the HRR guidance once we get under 18 hours. So in terms of doing some planning, let's say about 3 days out, probably want to lean on the NAM more, use a mix of the NAM and European. And then on the day of, if you're in the general area, if you want to find out what's the best town to be in relative to the area, let's say if you are visiting Western New York, but you want to know whether or not you want to be in Syracuse or Utica for this event, that's where you want to use the HRR and give you about an 18-hour window. Have we seen a storm of this magnitude in the past few years? Oh, absolutely. This isn't a super unusual storm. This is typical of the spring. We also sometimes see these storms in the fall as well. What this is all being driven by is a clash of three different air masses: the maritime air mass, the tropical air mass, and the polar air mass. During the heart of winter, we typically don't see this type of evolution in our storm development because we don't have the pure tropical air to work with. And in the fall, we usually don't have the polar air to work with. So, or should I say in the summer, we don't have this strong polar air mass to work with. So it's hard to get these type of dynamic storms. But in the spring, especially in the early spring, March, early April, you could definitely get these type of storms. And, you know, if it's cold enough, it could be an impressive winter snowstorm with thunderstorms within it. So this is not unusual in terms of the potential for these storms developing. But that's a great question, Ed. Good one. Well, with that, it is 8:50, and we are starting to get more flickering here. So we're going to close it up for the night. Now that I've answered all the questions and we talked about the storm evolution, my suggestions for tonight is hunker down, continue to hunker down, obviously. Tomorrow morning, use caution traveling, okay? You're going to still have windy conditions. The roadways are going to be wet. In the interior, you're going to have some icy locations. So take some time. Give yourself extra time for traveling tomorrow, especially around the morning rush hour. Conditions will be improving, but if you are around any of those high-profile vehicles, these wind gusts are still going to be an issue. Coastal flooding threats will start to subside with more of a northwesterly wind, and the worst conditions will be lifting up towards New England. If you have any outdoor plans for tomorrow, expect it to be a bit raw and chilly out, okay? So prepare accordingly, but at least the steady rainfall will be coming to an end. That's the end of our live chat for tonight. Thank you, as always, for coming in and asking your questions and joining. And as always, stay safe out there.